Welcome to the tutorial on the free vibration analysis of a composite cylindrical cell. An all-round simply supported cylindrical cell which is made up of cross-ply laminate scheme 090 is considered. It is a thick cell of S, which is the ratio of mid surface radius R to thickness is 4 and is of axial length L and circumferential span alpha. The material properties of a lamina are that of a orthotopic material. So, find the lowest natural frequency of the cell and visualize the mode shapes. The results are compared with those presented by Chen et al. In this paper. So, we can see the lowest dimensionless frequencies have been listed in this table. So, we model the model the cell, go to create new model database and set the working directory, create the new part which is named as cell vibration, and these are the construction lines for initializing the model. As the circumferential span alpha is pi by 3, so the construction lines are at an angle of pi by 3, and a arc is created at a distance of uh, 3.5 unit, which corresponds to the inner surface of the cell, and the thickness is taken as 1 unit. And close the sketch for extrusion, and it is extruded as 5s units, that is 20 units. Then the plies are created through an offset tool as previously explained. And a cylindrical coordinate system is also provided. Then in the property module, the material properties are assigned to the plies, and the material properties are those as shown in the problem statement earlier. The laminate scheme is taken to be 0, 90, 0. So the outer two layers are at 0 degree and the middle layer is at 90-degree orientation. Thereafter, we assemble the uh, we go for the assembly of the shell. And then we in the step module, this time we need to do the free vibration problem. So we go for the linear perturbation type and go for frequency. Using the solver of Langkos, the number of mode shapes that we want to calculate can be given in the values field. Then we set the boundary conditions, which is simply supported. And there is no load as it is a free vibration analysis. Then after the meshing is done, after a convergence study, and we take the 3D type elements. Finally, the job is submitted for analysis. So once the analysis has been done, the data file for the analysis can be seen in the working directory as a DAT file. In the DAT file, we can find uh, the calculated frequencies corresponding to the mode shapes. we can see the eigenvalues listed here. And on comparing the results after non-dimensionalizing, it nearly matches with the results presented. We can also visualize the mode shapes